Hi everyone, today I bring a very interesting question based on the motion of moth, which are insects which spiral around sources of light. Now you must have seen at night time these insects getting attracted towards bulbs or some sources of light. So let's see what the question says. At time 0, an insect is at a particular distance of 1 meter from a point source of light. Now the insect moves in such a way that it has a constant speed and its direction of motion makes a constant angle theta with the line joining the insect and the point source of light. So the question is, after how many revolutions the insect will touch the source of light? Before solving the question, let us discuss some basic concepts. So imagine there is a particle P and its distance from the origin is r, and this line makes an angle theta with positive x-axis. Then r comma theta is what we call polar coordinates. Just like x and y are what we call Cartesian coordinates, r comma theta are called polar coordinates. Now imagine this particle is moving in this direction with velocity v. Then this v can be written in terms of r, right? Because as this particle moves, this r will increase with time. So the speed will be the rate of change of this distance r with respect to time. So dr by dt would give you the speed of this particle if it is moving in this direction. Now what if the particle is coming in this direction? Let's say this speed is v dash. Then how would I write this particle? Well, now this distance is still changing, but now it is not increasing, it is decreasing. So if this r is decreasing, then we write this as minus dr by dt. So the minus sign here means that your speed is in the direction of decreasing r, not increasing r but decreasing r. Now if you notice in this example, the angle theta was not changing, only this r was either increasing or decreasing. Now let us see a situation where the r is fixed. So this r is not changing, but the particle is moving in such a way that only this theta is changing, which means it must be going in this circle, right? So it goes in a circle, then this r will not change, isn't it? Now how to find this speed? Well, after some time this particle may move by a small distance ds, and your theta will change by a small amount, which I can write d theta. And this ds, which is like an arc, can be written as angle d theta into the radius. The radius is r, right? And then if you divide this by dt, that would be your speed in the direction which is perpendicular to this r, right? And this ratio is also what we call as angular speed. Angular speed. And we give the symbol omega. So if the particle is moving in such a way that this r is constant but only angle is changing, then the velocity of the particle is given by r times omega, and your omega is d theta by dt. So this is the formula if only r is changing. This is the formula if only theta is changing. So now let's come back to the original question. Here is the moth, the insect, which is at 1 meter from the source of light at some particular time. Now they told it has a constant speed and its direction of motion, which means direction of velocity, makes constant angle with the line joining the source of light and the insect. Meaning, if right now it is going in this direction with velocity v, then this angle between the velocity vector and the line joining the source and the insect, that angle should be constant as per the question, which means it cannot continue straight. Why? Because if it continues straight, after some time the insect will be here, then after some time the insect will be here, after some time the insect will be here, right? If it continues straight. Now when the insect is here, this will be the line joining source and moth. This will be the line joining source and moth. This will be the line joining source and moth, right? So you can see if the particle goes straight, then this angle is no longer constant, right? This has become 90 degree here, see? So the velocity is now making 90 degree with this line. But they told the direction of the velocity should make constant angle with this line, the line joining the source and the moth. Therefore, our insect cannot go straight. So in what way the insect should move so that this angle remains constant? Well, next time when the insect reaches here, this will be the line joining the source and the insect. Therefore, it should make the same angle, it should slightly turn. Similarly, when it reaches here, this will be the line joining the source and the moth, and to make the same angle, it should again slightly turn. So our insect has to turn this way so that this angle alpha is kept constant. So for example, when it will reach somewhere here, this will be the line joining the moth and the insect, right? So when the insect reaches somewhere here, to keep the angle same, it should come this way, right? So this alpha has to be kept constant. So our insect will spiral this way. And we need to find how many revolutions it will make before it touches the source of light. So the path of the insect would be something like this. Okay. So now let us assume at time t, this is at time 0. At time t, the insect has reached somewhere here. So in terms of polar coordinates, this r would represent the distance between the source and the moth, which keeps changing, remember, and this would be the angle theta by which it has turned, right? The insect was here and now it is here, so theta is the angle by which it has turned. And when it is here, its instantaneous velocity is always along the tangent, right? And this angle should be same as this angle. That's what the question says, right? So this angle should remain constant. So now if you look carefully, I can take two components of this V. One will be here and one will be here. So this will be your V cos alpha and this will be your V sin alpha. Now compare this velocity and this velocity with the concept which I taught before. So if you look carefully, because of this velocity, your R is decreasing, right? So I can write this V cos alpha as minus dr by dt, right? Rate of change of this distance would give you the speed in this direction. And similarly, this V sin alpha is the velocity which is perpendicular to this R, and that can be written as R omega, and your omega was d theta by dt. So now if you divide equation 1 by equation 2, what will you get? V will cancel. Cos alpha by sin alpha will be cot alpha. And on the right hand side, dt will cancel. So minus dr by r d theta. Right? So if I cross multiply, I will get minus dr by r is equals to cot alpha times d theta. Let me put the minus sign here. So now what we do is we just integrate. So when you integrate here dr by r, the limits will be initial value of r, where r is the separation between the source and the moth, was 1 meter, and after some time it is r, right? After it reaches here, the distance is r. And minus cot alpha is constant, you can take it out, integral of d theta. And when it was here, theta was 0, right? And when it reached here, theta is theta itself. So if you integrate this, you will get integral of 1 by x dx is log x. So this is integral of 1 by r dr. So that will be log r base e. Upper limit is r, lower limit is 1 minus cot alpha, and this integral of d theta is theta. If you put upper limit and lower limit, you will get theta. So now if you put the upper limit and lower limit, you will get log r minus log 1 base e, and that will be equal to minus theta cot alpha, right? I'm writing the theta first, and then log a minus log b is log a by b minus theta cot alpha, and therefore your r will be e power minus theta cot alpha. Now let us analyze this equation. The first thing to notice is this cot alpha is constant. According to question, this alpha was constant. Now, with time, theta is increasing, isn't it? It is going to cover more and more angle. And this can be written as 1 by e power theta cot alpha, right? Power minus means this only. So if theta increases, this whole thing will increase and therefore your R will decrease, which is very evident in the diagram because with time the moth is coming closer and closer. Now the question is how many revolutions it will make, in other words how much angle it will cover before it touches the source of light. Now here the source of light is a point source. Therefore if this moth touches this point source, the distance between them will be 0. Now if this is 0, then what should happen? Well, the only way this can be 0 is if theta is infinity. Because if theta becomes infinity, e power minus infinity is 1 by e power infinity. And 1 divided by infinity is 0, isn't it? So therefore, in order for R to be 0, it should cover infinite angle. In other words, the number of rotations it will make will be infinity. Now, does it mean in reality the insect has to make infinite revolutions before it touches the source? Well, obviously no, because in real life, this insect and the source are not point-like objects, isn't it? So they will have some size. So if I assume this source has some definite size, okay, let's say this radius is 0.1, then meter, because I have to take it less than 1, right? Because this is 1 meter. Then by the time the source will reach here, the separation will not be 0, but separation between the center of the source and the moth will be this 0.1. Now this equation came from here only, and this is better to calculate theta. So small r will become 0.1, so it will be log of 0.1 base e minus theta cot alpha. So your theta will be minus log base e 0.1 by cot alpha. Now don't think this angle covered is negative number, though you may see a minus sign. That is because this itself is a negative number. Why? Well, you know that log base e 0.1 can be written as log base e 1 by 10, which is minus log base e 10, right? Because this can be written as log base e 10 power minus 1, and this minus 1 will come here. And when you substitute this here, minus minus will become plus. So log 10 base e divided by cot alpha. So if this alpha is given, we can find the angle it has covered to reach here. Now once you know the angle, you can easily calculate the number of revolutions, isn't it? In one revolution, the angle covered is 2 pi. So in n revolutions, the angle covered will be 2 pi n. So this angle can be written as 2 pi n. So therefore the number of revolutions, if you cross multiply this 2 pi here, will be this. Now you can change this number, okay? You can change this 1 meter to, let's say, something capital R, and this 0.1 as R by 2. And then repeat the question just for practice, right?